So I wanted to make a little bit better video of our setup on our Shapeoko 5 Pro here. And as you can see, you need a fair amount of real estate for this thing, table-wise. So when we started out with this, I designed up this frame for it. And a couple of unique things here is we've got these combination casters and leveling pads. So any kind of machine tool, you really need a base level on it that is repeatable and where you can take and have no rock in the base, and that you actually can adjust these into the point where your X and Y axes are perfectly level. The other really unique thing that we did is I designed these clamps, and of course we've got a main runner down the center of this table, but unlike a wooden table where you would have boards all the way across, we're basically supporting the machine from the two outside rails and the inside rails. But what's so important about this is we made up these adapter clips, and what you can do with this is if you want to twink this table in perfect, you can go each one of these corners and you can take and shim them to make sure that your table does not have any twist or swarf in it or whatever. And of course the only way you can really take and bring a table in perfect is you're going to have to go up here and put a dial indicator on the head and sweep the whole thing. And we shot it with a laser, and I mean it's like within 60 thousandths throughout the whole table, just with the way we put the clamps in here. So I mean it's really close. If you wanted to get in here and tune this, and we may eventually do that, I mean you can get it so it's within 5 or 10 thousandths on the whole table. And what the difference makes there is you know that if you're going to stay, if you have a Z plus 5 thousandths and you run the router all over the whole table, you're not going to hit any of the table base. So I mean, you can really take and make a really neat, much higher quality machine than typically most people will take and install this as. And we also have a board over there with all our controllers mounted on it, so it makes kind of a clean, neat installation. We still have some wires hanging around down here because we're having some issues and we're debugging them yet, and we're going to leave stuff loose until this thing goes through its prove out, and then we're going to tie stuff up a little bit better. As you can see, we have cut some foam with it. Primarily the idea of the purchase of this machine was to take and machine our foam inserts for shipping our products in here. And up till now we've actually used steel rule dies to cut openings and such, and now basically we're going to take and attempt to take and cut the foam from a higher density foam. Some of our products are heavier and the lower density foam isn't taking and handling the job for us. So this was the primary reason for the purchase of the machine. And our parts aren't that terribly big, but in the axiom of buying CNC machines, you can always cut a small part on a big machine. You can't cut a big part on a small machine. So my advice, if you've got the real estate and you go to buy one of these routers, get the biggest one you can get. Get the 4x4, because you never know. You'll never need it. It's like a seat belt. You'll never need it until you do, or a gun. So that's one of the things. One of the nice things about this so far, when we did get it running, is this variable frequency drive spindle. It's fast and it's quiet, and it is really, really nice. If you worked around routers before, please don't get the router. This thing is worth every dime. So we're going to talk a little bit more about the machine and how homes, and the problems that we're having right now is the controller believes that we never come off of this X switch, and that brings us to the point of how you take and how the control system on this thing takes and orients itself and how it runs. And then we're going to get into some other things. I've designed CNC controllers and motion control systems. I was a senior control engineer at Rockford Automation and many years ago. But this kind of goes over philosophy on machine design a little bit. What you get for the money here, I say it's well worth it, but here's the things that you can take and do a lot better. If you notice on all of your drive motors, these are stepper motors, that there's a shaft coming out of the end, and there's a reason for that, because you can take and put an additional encoder on these drive motors. And what that does is it gives you positional feedback from the stepper. This system right now, the way it is, or what they call an open loop system, and that means I tell the stepper to go so many clicks and it goes so many clicks, okay? And if something was to jam and it doesn't go so many clicks, you'll get an offset in your axis and your program will be weird because the axes won't be in the right position. The one thing about using an open loop system is it's less expensive. However, these encoders that go on these motors now are very, very, very inexpensive. So, and I think the Gerbil controllers out there will support the feedback. You might need more interface boards in there, but basically it will take and guarantee positioning. Another thing that, well, it's not terribly unique to this machine, is you have a drive motor here for Y1 and you have a stepper motor over here for Y2. Now, the controller's got to be smart enough to take and set those both at the same to get the bridge to be square. In other words, to get the x-axis square with the y-axis. And apparently the way this system works, and when it homes, it takes and it comes up, it hits the micro switch, and then the micro switch takes and it starts pulling away from the micro switch, and then when it sees the switch open, it zeroes the axis. And your machine reference 0 on this machine is Y positive, X positive, upper in the upper right hand corner here. So I actually designed some gantry machines, and instead of using dual drives on that, and we had a machine, it was a plasma cutter, and we used some precision timing belts and ran a shaft between the two with timing belt going around it. And the thing about that was so neat is to sync them, we had only one stepping motor, was going to run the y-axis, and it wasn't a stepper, it was a full-blown servo. I don't build stepper-based machines for industry. If they're going to be used in an industrial environment, running every single day, all day long, you're going to have brushless servos. For a router like this, there's nothing wrong with the steppers. However, one thing about the way this thing homes is it comes up and it will take and come up to the switch, then pull away from the switch, and whenever that switch releases and goes off, that apparently is where it zeroes the register. Now, proc switches are not that accurate. In other words, if you were to take and position home and reposition home and come up to a reference, you're at best probably going to be within 5 thousandths, but you could be within 15, 20 thousandths. On a router, you typically don't care about being that precise. On a machine tool, you absolutely, positively care about it. And this goes back to the idea of adding an encoder to the motors. And the way you really need to reference that is you're going to come up and you're going to hit the switch and you're going to stop. On the rotary encoder, there's always a marker pulse on it, and you take and hit your switch. You're going to come away from your switch, but you don't care about the switch at all anymore. What you're going to do is you're going to keep moving and moving, and when you see the marker, that's going to be your axis register 0. And the neat thing about that is if you home a machine like that, that's going to repeat all the time. And what you can do then at that point is you come over here and you get a master square on this machine referenced off of the y-axis, and you put an indicator in here and you run it back and forth, and that's where you can take these 2 bolts here and you can square this machine up so it will cut a perfect rectangle or a square. If you're skewed a little bit on this axis, you won't get a perfectly square square. Does that make sense? So, and you can do that with the multiple drive systems. You don't have to have a shaft like I did on the machine that I had designed. You can take and do that with this, because once this thing, once each one of the y-axes, y0 and y2, take and reference themselves, then you're going to take and adjust this off a master square and sweep it in, and you're going to be dead bang. The rest of the videos on assembling this machine are pretty much dead on. You want to take and square corner to corner, and that's going to give you your rails. Then they take and say run your gantry up and down as you tighten your screws here, and that will take and then a big master square as you're getting everything in, and you just basically, that confirms what you did from corner to corner to square it. Once again, like I said previously, if you're going to get this table dead flat, at that point, once your axes are all up, you're going to take and throw an indicator on the spindle, bring it down to reference height, and then you're going to take and walk the whole table. If you want the table absolutely perfect, okay, let's say I got the table in and I've got it within 10 thou, and I want the table absolutely perfect, what you can do is come down and take a 5,000 skin cut or a 10,000 skin cut across all of the wood here, and at that point in time, you have a machine as dead perfect. Your Z from the table, reference Z, is going to be dead perfect. And that's the way a lot of bigger machine tools are built. You actually are going to take and machine the table in with a skin cut after it's all done, provided you know that your geometry on both your rail systems is dead bang, and you know that you're cutting square and everything, and then you can machine that table with that skin cut, and everything will be just perfect. So far, I'm not disappointed. As soon as support gets me a proc switch or we figure this out, well, actually, I'm going to take and get meters out and find out what's wrong right now, and then I'll follow up with Carbide 3D and let them know what's going on. Oh, one more thing when you're assembling this. These tracks, you pop them out. This particular track comes with the wires in it. The other ones don't, and you have to pop these things open. You need to really kind of watch how you do it, because it will take and break the link right in here on them, and then they won't hold shut. The one side will be flopping around. And we needed to replace a few of them. And if you do break one, and I don't know if there's one shown here or not, if you do break it, take the whole link out of it. Don't leave the link in there, because it could flip open and then you'd have more problems, in that regard. The other thing that's really nice is this LED light over especially when you get older and you need more light, this LED light over the x-axis is just great. It does a great job of illumination, and those are the little nice things that we really like about the router system, and this VFD motor here on this is just awesome. It's quiet, and it's got tons of RPMs, and when you're routing, that's one thing, surface foot and the foam and everything, you can just go crazy. The higher the surface foot you can get, the better. And the only thing that we're seeing is this looks like it's an 8 or 9 minute route on this, and I was hoping to be able to take, and this is a typical dunnage for one of our parts, I was hoping to get this down to 3 or 4 minutes. The collet will go up to a 1/4 inch, but I'm wondering if I can't get a turn down on this and maybe get like a 3/8 tool in there. And then I'm pretty conservative in my step downs on here because we're just running it, and I didn't really want to take and wrap up foam and yank the foam out of there, but it did a really good job. And this was our first cut here, so that really doesn't count, but right in here, I mean, it really did a nice job. Just gotta need to go a little faster. And we were in the middle of this cut, and we lost power to the PC, and that wasn't really a bad thing because that will tell you how to recover the machine. And so far, unless somebody tells me any different, if you have a problem here and it shuts down, then you should be able to rehome it from there. In other words, it does things right. It pulls the Z-axis up first and then moves it out of the way in X and then moves it back in Y. So our basic issues with this homing switch here, and you probably could switch it with another switch, except the connectors are keyed on this when you get it in. You can't miswire it because it's each connector, each place where it joins together is unique, so you can't mess that up. And there's a fair amount of connectors that you do have to put together on it, so you know that's really a nice feature for the hobbyist and whatever, rather than having to take and wring out wires otherwise. So hope to get this thing online. I thought we had it online here, and the only other thing that we did find came in, and I probably can see this, is this one part here was cracked, and we'll get that over as an issue too. And they do give you, and when you have trouble with these tracks, they do give you 3 or 4 spare knuckles that you can put in there and replace it. So it's probably kind of a known issue that these things can get wrecked when you're putting them together. And the other thing too is tracking on this. You can't really tighten these too tight because they're really into plastic and stuff, but if you don't get the screws tight on here, your tracks are going to take and tend to wander back and forth off of here, and that's never a real good thing. And we were looking at it thinking, well, maybe on the machines that I designed, I designed a trough for them, so it was a guide, and of course it was a bigger machine. This is like about a 3-inch wide track on the machines that I designed. And but it did have a trough, so as it went in, and it had a flange on it, so it would always track it and keep it right on top of the rail. So, but it went together relatively easy, and it came up relatively easy, and we just got a few things to do, and I actually have a chunk of foam for production. And we were planning, and we got a die that's getting ready to go out tomorrow. I was planning on actually shipping the first production die in our foam cut machine. So, and we got the sweeper for it too, which we haven't got set up yet. And I got the spindle mounted pretty high on the Z-axis, more or less as a precaution than anything. And so there's minor twinking to be doing. Like I says, all the wires are going to get tied up and tidied up. You'll know, one thing that I don't know is in the instructions or not, is these rails come with these stick-on wire pads, and we didn't know at first to put the rails with them to the left or to the right, and then we saw it was to the right. But we're running a lot of wires down through this thing, and I think what we're going to do is get these out of here, put them back down on some pads that, you know, are under the machine here. And we designed the table slightly narrow. I think just to take and get clearance for the controllers that we mounted back there and such. So you got a clean edge as you're looking down the machine this way. And with our bracketing system on this, we can actually, we oversize the table in Y on purpose. And that is, you know, you might want a little staging area here as you're running product in and out. And right now we've got, you know, the computer sitting on this. If we needed more area, we could always loosen our clamps and move the machine back or forward. And then in the back side, I figured, well, you might want a little area there to have a little shelf on that just for miscellaneous stuff at the back, or if you want to work on something back here and you want something to set tools on, thought that it'd be nice to have that. So it's not totally 100% done, but it's 100% looking good. And, you know, we hope we get, you know, a fair amount of life out of this. It wouldn't be that horrible a job to actually put encoders in this and rework the controller on it and get it so it was a closed loop system. But it's one of these things like, you know, if you don't need it, then it just makes things simpler. And if you do blow, if you have an encoder system on it and you go to blow an encoder, then you're going to shut the machine down. But if you have an open system and you got a stepper that is starting to take and act up on you, then, you know, you can take and if you have an axis hang and then starts positioning again, it'll track your G code, but it'll have an offset in it, and whatever you're making will be garbage. So, you know, 6 one, a half dozen the other. But really, this is how you really need to set up a new machine. And no matter what, you can buy a $150,000 VMC and they can set it on the floor, but it's never ready to run. It's not ready to run until you've done your prove out on it and you've checked various things with it. And of course, then there's, you know, tool change cycles, et cetera, which would be kind of neat if this did have a tool changer on it, but they are the worst things in the nightmare. The worst nightmares you can have is a tool changer, because it's hard to make a good one that's reliable. But other than that, I think that pretty well sums this puppy up. And I'll throw this up on our company YouTube page. And if you'd like to see what we do for products, you can skip on over to www.panelpunches.com, and that's es.com, and you can see what our regular items are. We are pretty well worldwide known now for specialty knockout punches for all sorts of industries. So, and I may follow up with an update on this once we're under production. We'll take some videos of some of the foam cutting and some of the stuff that we found out cutting foam. It actually wound up being a lot easier than I thought it would be, but we've cut an awful lot of different kinds of material here. And incidentally, this may be cutting some aerospace parts, some honeycomb structures for an experimental airplane. That's another reason why I kind of got it in here to take and get used to it and get going. And that stuff will be a lot messier. We got a sweeper with it, and we just haven't put it on there yet, but we will get that on and have that running even on the foam. And the foam really wasn't as nasty and dirty as we thought it would. What was there, we vacuumed right up. I think if we had the sweeper on it and running, it would be very little material that you have to worry about getting scattered around and getting in the computer and everything. So I guess that's about all I have to say about our Shapeoko. It looks like it's going to be a good machine, you just got to do that last mile and we should be all set to go. We invite you to come on over and take a look at our website at www.panelpunches.com. You can see a variety of our products here, and we do ship worldwide. Take care and have a great day.